Welcome to Scholar Opportunity Nexus, and in today's series of video, we'll be looking at addition of parallel vectors. As said earlier, a parallel vector is a vector that there are two vectors that are inclined at an angle of zero, or there's no angle of inclination between these two vectors. Something like this vector and this vector, they are parallel vectors because they are not inclined at any angle. These two vectors would never meet. Something like these two would never meet. They are all parallel vectors. So now taking this, let's say two vectors are moving together. How are we going to add them, or what is the resultant or the sum that would come out from those two vectors? What will be the resultant? So in this case, we can add vectors. First of all, vectors can be added together to get a resultant vector. So taking a parallel vector, one, to add them, you just have to look at their direction, whether they are moving in the same direction or they are moving in an opposite direction. So let's say vector A is moving in this direction and vector B is moving in this direction. And you have to add these two vectors to get a vector with a magnitude. No, note that we are adding their magnitudes. Their direction will just be shown, whether they are moving in the same direction or they are moving in opposite direction. They can be moving either to the east, to the west, to the north, to the south. That's when you are considering it with the cardinal points, the north, the east, the south, and the west. We can consider them in this form. But when adding them, one thing you really have to note is their direction. Yes, their direction really counts. So let's take a question. A boy is moving at 7 meters per second due east, and his dog is moving at 8 meters per second in the boy's direction. Find the resultant sum of their velocities. So in doing this, we can represent it on the Cartesian plane, the cardinal point of view. So the boy is moving due east. So let's say the boy is b 7 meters per second, and his dog is also moving due east. That's along his direction, 8 meters per second. So d 8 meters per second. So to find their resultant sum, the resultant sum will be the sum of the two. So let's say VR be the velocity of the boy plus the velocity of the dog. We are adding them, and since they're in the same direction, we'll have to add them. We are adding, that's 7 plus 8. That would give you 15 meters per second. So this is the resultant of the two vectors, or that's the resultant of their vectors, the sum of the vectors of these two bodies. Now, let's say these two bodies were moving in different direction. So taking this same question, but so let's say opposite, opposite the boy's direction. So now the dog is moving opposite the boy's direction, meaning over here. Oops. Meaning over here, come in, let's clean this. Meaning over here, the dog is moving in this direction, 8 meters per second. Have to clean this. 8 meters per second. So in adding parallel vectors, and if two vectors are parallel and they are moving in the opposite direction, one thing you have to know is you'd negate the smaller vector. The smaller vector is always negated irrespective of where the direction is going. So in this case, you see that the boy's velocity is 8 meters per second and the dog's velocity is um, the boy's velocity is 7 meters per second and the dog's velocity, that's D, is 8 meters per second. So in getting the sum or the resultant sum of these two vectors, we know that one, we always have to negate the smaller vector and the bigger vector remains the vector remains positive. So one vector has to be negative, one vector has to be positive. Which vector will be negative? The vector with the smaller magnitude will be negated, and the vector with the positive, um, the vector that's positive is the one with the bigger magnitude. So in this case, you see that D would be positive 8 meters per second and B would be negative 7 meters per second. Now adding these two vectors, we have 8 plus negative 7, and this would be equal to 1 meters per second. So the resultant of these two vectors, since they are moving in opposite direction, would be 1 meters per second. Assuming they were moving in the same direction, you just add them. Different direction, you look at the one which is which is smaller. The smaller magnitude or the vector with the smaller magnitude will be negated. Let's take another example. So let's see another example 2. The, the car is moving due south in a bike is moving due north. So we have to find their respective velocities. So for car A, for the car, that's A, vector A, its velocity is 15 meters per second. And for the bike, which is B, its velocity is 20 meters per second. So we have to find, let me clean this line. So we have to find the resultant or the sum after adding these two vectors, moving after adding these two vectors. So let's draw it using the we are coming to draw it using the cardinal point of view. Drawing this. Wow, that was straight. North, east, west, south. So The car is moving due south 15 meters per second. Due north is for the bike, that's 20 meters per second. So it's the same thing for these two. They are all moving in different direction. That's they are opposing each other. They are moving in an opposite direction. So in adding these two vectors, what do we have to do? One, we have to look at the magnitude of these two vectors as we did in the earlier example. So we are still coming to look at the one with the smaller magnitude. Looking at this, car A has a magnitude of 15 meters per second and car B has a magnitude of 20 meters per second. So the one which will be negated is obviously car B. In vector B, that's the bike, would be the positive. So the resultant would be 20 plus minus 15. Adding this, you get 20 minus 15. That will give you 5 meters per second. Let's say they were all moving in the same direction. So assuming they were all moving in the same direction, then let's just forget about the description made here and assume they were all moving in the same direction. For that one, meaning you just have to add the two vectors. You won't negate any because they are all moving in the same direction. That will be 15 plus 20, which is equal to 35 meters per second. And this is how we solve addition of vectors, that's specifically parallel vectors. This is how we solve them. So in a case where we have two vectors, one moving due north and the other moving due east, how are we going to add those two vectors? We'll look at that in our next video. Thank you very much for staying up till this point, and I hope to see you in our other videos.